So let's circle back to the question that we had before. So here everyone agrees this is virtual image? Yes? So you might say that the image distance is negative when the image is virtual. Right? And all of that's good when you are dealing with this simple situation. But once again, how would you know? Let's say if you are looking at a ray diagram like this, and well, were you? Let's see. No, I guess if you have ray diagram, then it's pretty easy to tell when your image is virtual because they don't actually come together, and when they are real because they actually come together. So suppose you don't have ray diagram. All you know is you have object somewhere, you have lens somewhere, and all you know is where the image forms. It forms on one side or it forms on the other side. What one criterion would you use to say this image is definitely real or this image is definitely virtual?
The sign conventions? The sign conventions?
Well, so we are trying to use the criterion that it's either real or virtual to determine the sign conventions. So let me reform the question. So I guess this is where it matters. So here you are given the object distance and then asked to work out the image distance, right? What if you are given it the other way? You are given the image distance and then you are asked to work out the object distance. And you might even be given the information this way. You are not given di as assigned quantity from the beginning. Instead, you are told image forms at some distance away, and you are told where the image forms. Image forms on the right side of the lens, or image forms on the left side of the lens. And from that, you have to figure out, so problem might tell you this. Image forms 30 centimeters from the lens on the right side here. Or image forms 30 centimeters from the lens on the left-hand side. From that information, you need to figure out, is it plus 30 centimeters or minus 30 centimeters? Like, what criteria would you use?
Do you know which side the object is on?
You might know which side the original object is on. Okay, let's say you will always know where the light comes from. So you could say object is on the left-hand side, which is another way of saying the light comes in from left and goes out to the right. So let's say you do know that.
It would be if it's on the same side as where the light comes in?
Same side as where light comes in. So that's one way of describing. Let me do it the other way. So whether it's on the same side as the outgoing side. And I will explain why that little nitpick. So this is how I want to refine these initial guesses. Instead of saying the image distance is positive when it's a real image, I want to instead say image distance is positive. I mean, it's going to be the same thing as real. It's just clear how to apply it. It's on when the image is on the same side as outgoing rays. Now, you might wonder, isn't this the same thing as opposite side of incoming rays? There's a slight difference. Let me explain that after I've replaced this. So instead of virtual, we would say, I still use the phrase outgoing side. So outgoing. So for virtual, it'll be opposite side.
Is it for a mirror?
Yeah, it's considering applying the same convention for the mirror that I'm being very careful in using this language. None of the physics textbooks I know are this careful. They use other language that forces them to come up with the two different sign conventions for lens and mirror. And I think it's counterproductive. You can use one sign convention for lens and mirror if you are careful in how you describe it. So in case you didn't, so this is what I want you to imagine. So this is what you saw with the lens, right? Outgoing side, real images here, all good. Now imagine you have, and this is the opposite from the incoming side. But imagine you had this mirror here. Sorry, I'm not going to draw it because that diagram is already complicated. But imagine you had this converging mirror here. Then what you would get is these light rays would reflect off from it, and the real image would form somewhere here. And it's on the same side as incoming rays. So if you were describing this with the incoming rays, then you would be forced to flip the rules for mirror. And maybe you will remember which is which, but it's unnecessary confusion. If you describe the outgoing rays with the mirror, incoming side and outgoing side happens to be the same side. And if this was with this converging mirror, if this object were closer, your virtual image will form on this side, which is the opposite from outgoing side. Okay? So that's the sign convention so far. I guess, so from last time, you guys know when f is negative, right? When is it negative? When it's diverging. Yeah. All right. Do people want to see example 3 again? I guess I could do it again, but if all of this makes sense, I would rather reserve the time for something more fun.